right, well, I want you in your sphere exercises to get some intuition for what lines and angles and triangles behave like when you're on a sphere. And so I've got a bunch of experiments that I want you to do using string and some sort of a ball or an orange that you can find, so that you can experiment with what happens when you try to make shortest paths on a sphere. And I'm going to now just kind of show you a few examples that I'm hoping will just kind of help your intuition a little bit, so that when you get to the questions, that the answers you're finding are going to click and make sense for you. So back to Google Earth for a few minutes. So when you think about Google Earth and you think about, let's see, I want to change this so that north looks north again. There we go. There's what I want. I want north to look like it's up so that I know where I'm at. Okay, so here I am on Google Earth. If I just draw a line and I ask Google Earth to find me a distance, and I draw this kind of right in front of me. So you got to imagine that you have your sphere or your ball and you're looking at it straight on, and you just kind of draw that line going straight down, and that's what it looks like. It all works nice and normal and happy. And if I tilt the Earth a bit and I do the same thing, that same trick is going to work and give me a shortest path. So if I want a shortest path from up here in Canada to, let's go to Scandinavia. Okay, so there's a nice short path. And if you look at that sphere kind of head on, that looks straight. And if you were to do this with a piece of string and you're just going to stretch it tight so that you got the shortest path, sure enough, that would be a shortest path. And so that kind of fits. I'm going to turn back on the grid lines, the latitude and longitude lines, because a thing you kind of have to get used to is that straight path doesn't follow the latitude lines, right? So if I were going from somewhere, even if I was going from two places with the same latitude, so I'm going to pick that point in Canada and this point in Europe that are both 50 degrees north latitude. If you look there, when Google Earth does its shortest path, right, and if you tilt the sphere so that you're looking at it head on, it looks straight, but it's not following the latitude lines. And so that's a thing that you kind of have to get used to, is the idea that latitude lines aren't really lines. They aren't straight. So we call them latitude lines, but really they're latitude circles. A line is something that's a shortest path, and latitudes aren't shortest paths. Except for our favorite example that we did a little bit ago, which is at the equator. The equator, that special latitude that's the equator, that one is a shortest path. The longitudes, so if I pick something at a particular longitude, try again. Okay, I want a new one. New one. Okay, so let's see if I can line it up with this one. That looks Okay, so I'm going down that longitude line. You should be able to tell that that shortest path goes straight down the longitude lines. So the longitude lines, those are lines. Those are shortest paths. And when we talk about infinite lines or extended lines on a sphere, what we're going to do is we're going to take that line that goes all the way around the sphere. And it gets called a great circle. And it's just what happens if you head off going around the sphere and you come all the way around to the back. So let's see if I can do that. I'm going to make my latitude, longitude grid lines disappear for a minute. And I'm going to try and make a great circle that is not the equator. So I'm going to start at a point, and I'm just going to go in some direction, any direction at all. And I am going to make that shortest path. And so it looks curved when I turn the Earth this way, but if I turned it so that I was looking at it straight on, it would look very straight. And what I'm going to try and do is I'm going to try and turn it so that I can extend that. And so the closest I can get it by looking at it, that is going in the same direction. And then I'm going to try and get it going, keep it going in the same direction still. Pretty good. I'm going to see how close I can get to coming back exactly to where I started. That's pretty good. Oh, this is annoying. I can't see properly. There we go. That distance box is in my way. Oh, there. That looks nice and straight. Okay. Oh. Ah. What happened? Okay, still looks straight. Something happened to the Earth and it is no longer, it's like moved down on me. Well, I messed up a little bit. I didn't keep it quite straight. If I had kept it straight, I would have come straight back to where I started. Okay, Earth, recenter, please. Oh. Oh. Huh. I right-clicked. That was interesting. So that's an extended line. It's a great circle. It's what we call a spherical line. And so I'm going to go back to the latitude-longitude picture for a minute. Okay. So I want to think about if I was going to try and go on two parallel paths. So I want you to think about if somebody started here on the equator at 20 degrees west and somebody started here on the equator at 10 degrees west and they both went due north. That would be pretty close to being parallel. They would both be going due north. They'd both be going the same direction. But eventually they would both meet up at the North Pole. That's an interesting thing that happens. Turns out that great circles always intersect. So you can't have two great circles that don't intersect the way parallel lines don't intersect. Let's think about angles. So, no, we'll leave the grid lines for a minute. Well, maybe not. I don't know. Okay, so I want to think about angles for a minute. And so I'm going to use this distance tool so that it will give me shortest paths. And I'm just going to go one straight path and then another straight path. And so that is an angle. And even though these curve in space to follow along with the curvature of the Earth, we can say that there's an angle between those two curves. And that's going to be the angle that you would have at a tangent line projection, so a tangent plane projection, so you could think of having a tangent plane that meets right here. With something really big like the Earth, then you can just think, oh, well, what if I was to zoom in? Well, if I zoom in, then those are just going to look like straight lines to me, and I can just use my protractor right here. So the idea of measuring angles on a sphere is that you are taking these two spherical lines, and you are saying, okay, if I look at the direction this spherical line is going, and the direction this spherical line is going at that point where they meet, I'm going to measure the angle between those two. So there's some tricks for letting you do that with an actual sphere. I'm going to show you one really famous example of a triangle. And so for this triangle, I want to turn my latitudes and longitudes on one more time. And so this is going to be a very, very big triangle. I'm going to start at the equator, and I'm going to go up to the North Pole. There, North Pole. And then I'm going to pick another one of these longitude lines coming down. And I'm going to go all the way down to the equator. And then I'm going to go back over to the point I started with. And so I want you to think about that triangle right there. And so if you think about that triangle right there, you should be able to think right down here on the equator, what's going to happen if I zoom in at that point? What's going to be that angle? And that should be a 90-degree angle between the equator and any one of these longitude lines. So I got a 90-degree angle right there. And then over here, where we meet the equator again, I should have another 90-degree angle where this longitude line comes down and meets the equator. And what about up at the North Pole? Well, this is one of the easy places where you can see angles coming out of the North Pole because those longitude lines are named after those angles. So this is named the prime meridian, so that's like 0. And I went over here to 50, so that's a 50-degree angle. So that's a weird and cool example. And somehow I have gotten my sphere mixed up again. That's a weird and cool example of a triangle that has two 90-degree angles and a 50-degree angle as well up at the top. So, interesting things happen with triangles and with angles on a sphere.